Hi everyone, welcome back. So in this video, we are going to see how to insert at any position in a doubly linked list, right? So I have discussed the theory in a separate video, and the thing is, I forgot that. So let's build up from scratch and how do we actually write the C++ code for that. Okay, so let's write the code void insert at position, right? And it would take what? Int value and int position. Where do we actually place that node? So the idea is after inserting at a given position, the node should be at that given position. Let me rephrase that. If you insert a node with this value, the returned linked list should have that node at this position. And I am assuming position 1 is the first node, position 2 is the second node, and so on. Based on this, I am writing this code. Okay, so the very first thing is, first we check if position is equal to 1, right? If position is 1, or let's say before that, let's just create that node that we have to insert, which is this new node, and it would have what? Value initialized as val. Okay, so position is 1. So in that case, what this means is that we have to insert this where? We have to insert this at head. So what I would do is basically do the insertion at head code. So the first is new nodes next would be this head would be this new node, or before that heads previous is equal to new node, and finally this new node would be the head itself, right? So that is the thing. That is when position is 1, you insert at head. Now to reach the node position, what you have to do is to reach the node position -1, and to reach there you need to jump position -2 times. So let's do that. First, I'll take a temporary node and initialize this to head. And one more thing, after you've done the insertion, you just return. So let's take this head, and for int I is equal to 1 to I less than equal to position -2, then I plus plus. So what this would do is actually jump position -2 times. And what I'll do is I'll update this temp to temps next. Now a couple of things that you need to take into consideration, that if at any point temp becomes null, so and temp, so if I do this, my temp is not null. This is what I'm trying to check. And if it is null, I would get out of this for loop. So if temp is equal to null, or I can say not temp, in that case, what I would do is just delete this new node and then return. Fine. That is the idea. What we are trying to do, if this temp is null, that means we are trying to go to a position which does not exist. So currently we are trying to go to a node just before the given position, right? And if that exists, then we can add that node to the list. So that is the idea. So if temp becomes null at any point, that means we don't have a node just before the given position. And if we don't have the node just before the given position, we cannot add another node. So at this point, I can conclude that if I go beyond this line, I can actually add that node to my list. So that would be a valid insertion. So I delete this node because I have allocated memory for that. So that is why you delete before returning. Okay, before writing the code beyond this, one more thing that you could check is that if position is less than equal to 0, you just return. Because if for some reason you give a value which is not a valid position, because I'm assuming the head to be the first node, position 1, so any position less than 1 is an invalid insertion location. So in that case, I would just return. Let's just add the parenthesis. Okay, so that's about that. So after this, I am at a position that I can definitely do the insertion. So a couple of things, there are 4 links. The first one is temps next, and temps next nodes previous, that's 2 links, and the 2 links of the new node itself. So let's just initialize the new nodes next and the previous. So new nodes next is what? Temps next, as discussed. New nodes previous is what? Is equal to temp. And now what I have to do is, of temps next, the node that is after the temp in the original linked list, I need to assign that node's previous to this new node. So what I can do is temps next previous is equal to this new node, and what I have to do is to set this temps next to actually this new node. Now, one thing that we are actually missing in this is that what if the thing that I've highlighted, temps next, is null? That could be possible, right? Because I know temp is a valid node. I know this new node that I created is a valid node, but I don't know if temps next is a valid node or not. So in that case, what I'll do is I'll just add an if statement. If this, then do the update. So let's just add the parenthesis. So if temp next is a valid node, then only you assign the previous of that node to this new node. Otherwise, that's the assignment. And after this, you can just return. So that is the insert at position in a doubly linked list. We've taken care of the next and the previous pointers. We've taken care of the creating of the nodes which are not required. If for some reason you don't want to do it like this, what you could do is you can always declare this new node inside this if statement, or after this this if statement after this, or within this you can just initialize this, but why not? Okay, so let's do this insert at position. And what do we insert? I would insert this at position 1. Fine. So let's see what would happen. One more thing, you might think, what if the head is null? So in that case, if head is null and position is not 1, okay, so position is, let's say, 2, 3 or something like that. So what you would do is you would directly go into this statement. You won't go inside this. You would assign this temp to null, and because of this temp is null, you won't go here, and then you would come out of this statement. So even if the list is empty, this should work fine. So let's just compile this and see what is going on. So correct compilation e.exe, and let's just run. So as you can see, we are having some issues. So constructor called, but the destructor is not called. So where is the issue? Okay, so I found the issue. Issue is in this initialization of head. Head is a new node, not new node is not equal to head. So let's just do this again, compile this, and let's just run this again. One more issue. Okay, so the next issue is a very petty issue, that because I have considered that in this main loop, but I've missed that in this thing, which is that head is a valid node. Only after that you can actually perform this relinking of the previous node. So that is why we were getting a segmentation fault. Okay, so this should work now. So let's see what is happening. I insert 1 at position 1, then 2 at position 1, 3 at position 1. So this is basically insert at head. What I can do is I can do I comma I, and what would that do is this is insertion at tail. So when the linked list is empty, insert node 1 at position 1, then node 2 at position 2, node 3 at position 3. So you see, we are always inserting at end. Now let's do something like this, that dll dot insert at position. What do I insert? I'll insert, let's say, 99 at position -1 and print that. So what I'll do is I'll copy paste that and do for various. So if I insert it at 5th position, if I insert it at 100th position, and let's say -1000. So what I'm trying to do is do the inserting at various position to see that if the function is working correctly. G++, compile this, and then I run this. So initially in the first two, what I do is first this is printing the original, the insertion. Now after that, when I insert 99 at position -1, nothing happens. When I insert 99 at position 5, so it's at position 5, and after that it still stays at position 5, but the remaining are out of bound access. So that is why you don't get anything as your output. So that is the video, and hope I was able to explain this to you. The code is quite simple, it's easy, and I think in the explanation I had missed this as well. So be sure to correct that if you are coming from that video. So that is all about this video, and I'll see you in the next one.